So, ladies and gentlemen, welcome back from the networking session. We now enter the API and data session, where we all dive into the fascinating world of safeguarding APIs and unlocking the power of data. So, let's continue our journey of exploration and learning. This morning, we heard about the future trend of API ecosystem. Before we drill into the actual power of data, we should concern on the API and data security. Let's introduce our speaker from Nginx part of F5, Shain Singh. He's the lead security architect at F5, where he has worked with organizations across Asia Pac. Shain is also a project co-lead for OWASP Machine Learning Security Top 10 project. Please join me. Welcome, Shain.
Hi, good morning everyone. Thank you for the opportunity to speak. Before I start, I am Australian, so if I speak very fast, there are probably a lot of slides. I will be around all day, so hopefully I can answer any questions. Before I start, I just wanted to check, can I get a hands up for those people that would consider themselves developers for their roles? I just want to get an understanding of how many developers we have. 1, 2, 2. Oh, okay. Not a developer crowd. Okay. This is largely a developer talk. And it's somewhat technical. Okay. So when developers look at ecosystems, this is the API landscape. This is typically what we think about, right? All of the things that we connect to, all of the services, so on and so forth. What I'm going to try and teach you is, hopefully impart on you, is how security people look at ecosystems, right? And how developers, and we can all help security folks understand the environment so that we can uplift our security, right? But firstly, I wanted to put up some numbers. Now, the initial reaction to these kinds of stats is, oh, we need to talk to our developers. They're not doing a good job. We need to educate them. No. I want to tell you that this slide is actually an apology from myself and the security industry and technologies, because we are not working in the development way and their processes, right? So largely, these numbers are a failure of the security industry to integrate into pipelines, to work in DevOps methodologies, right? So this is not a bad slide about developers, this is about how security folks can do better. So, who am I and why am I apologizing on behalf of the security industry? It's a bit of an eye chart up there. I work at OWASP and I lead a couple of the projects there. The Machine Learning Security Top 10, similar to the API Top 10, is the Machine Learning Security Top 10. Another project is the Machine Learning Security Verification Standard. As well as that, there's a Cloud Security Alliance, and I work in the working groups there with DevSecOps and the Zero Trust working groups. When I have time, the job that I get paid for is at Nginx F5, and there I have 2 roles. I lead the security architecture team for Asia Pacific, and I also work in the open source program office at F5. So, this is a slide more for security folks, and this is why security is failing in terms of APIs and development methodologies, right? This is a maturity model for DevSecOps, and largely what security folks have done is they fine-tune and start working on specific things as opposed to complete coverage. So the idea here is more for security folks to, you would have seen this if you're working in your development pipelines. For those people, I should just say, if you are taking photos, I'll put a QR code at the end so that you can get my slides. Thank you. So largely the security maturity model here for security folks is about initially, you should not be breaking builds. You should never be breaking builds for security folks. You should be injecting tools into pipelines and then slowly working with developers to work out how it is that you're getting the best controls, and do that across all of your assets before you start fine-tuning and work through those processes, right? Now, this is how a security person looks at the word ecosystem, okay? So whenever a developer says, I'm building a service or an application, automatically what goes through their head is all of that common infrastructure stuff, right? This is largely the connectivity and availability of the application of service that you're delivering. So without even thinking about it, those are the things. For every single ingress, for every single FQDM, for every single API call that you make to a third-party service, you have to think about these things, right? So this is to give you an understanding of how security folks look at ecosystem, right? And all of these things have different names depending on what environment you work in. If you work at a data center level, you call them load balancers. If you work at a Kubernetes level, you call them ingress. Same thing, right? It's load distribution. DNS, the world does not run without DNS, right? Your APIs do not run without DNS. Denial of service, API protection, so on and so forth, right? Similarly, when you look at that common infrastructure, you now blow it out across all of your environments and assets that you're working through. This is only a small subset. This is not everything. But this is not just all of your environments for where you're deploying applications. This is also your environments for where your build systems run, where your operational systems are, where your monitoring systems are. All of those may not be on-prem. You may be using SaaS services for your monitoring. You may be using GitHub or GitLab, SaaS, for your build systems, right? All of those are part of the integration of building an application, and this is how security folks look at these sorts of things, right? Now I go down to the cluster level. So this, lots of stuff going on here, right? But again, when you say to a security person, I'm exposing a service on Kubernetes, automatically, and you say, I'm doing APIs, at least to me, I start thinking about all of these things. First thing I say, are you doing GraphQL? Are you doing gRPC? Why do I think about those things? Because they're not clear text protocols, right? gRPC is a binary protocol. I can inject attacks inside that. Your traditional tools will not see that, right? Similarly with WebSockets, amazing things for innovation, right? But it's a two-way connection between a client and a server. That should freak a lot of people out. You're getting a complete connection between a client and server without anything else in between. Now, all of these things here, those common infrastructure, they are as important down to the Kubernetes level, right? And what I want to get across here is they're not just important when you're exposing it to the internet. You know, last week, I'm from Australia. Last week I was at Kubernetes Day, and the CTO of Solo.io, service mesh company, he was talking, and he had a really good slide which said it's a security fallacy to think that your attacks are only coming from the internet. This is not how the world is built anymore. We shouldn't be thinking like that, right? So why is it that we don't do security if we know all of these things? And again, this is because the security tooling and infrastructure is not built to work in development pipelines or development tooling or development language, as Patrick put it earlier on today, right? A little bit of a happy slide, I would say, right? Here is some of the things that we are now doing as security best practice, which is absolutely second nature to all developers. If I said to you 10 years ago, you need to ACL traffic to any of your applications, you would say, I only need to do that on the internet. I trust my internal users, right? But now you have things like Docker service rules, you have Kubernetes ingress, which does all of the IP tables. Guess what? They're ACLs. And you do that without even thinking. If I said to you 10 years ago, you should really encrypt all your data. No, too complicated. Mutual TLS, you don't even think about it. Let's encrypt. You don't even think about it. You don't even need to generate your own certs. So these are successes in security, right? And why they've been successful, they haven't come from the security industry. Very important to understand that. They've come from developers with a security focus to make them work the way that they want them to, right? And so certainly with the things that F5 work with, in terms of the infrastructure, the premise we have is, well, WAFs have always been complicated. API protection have always been complicated. I only need to do them on the same things, right? Internet-focused things. Why? Well, we haven't made it ridiculously easy, right? Not just us, but the industry. So what if we could make things like web application firewalls, authorization, denial of service, all of those controls work in the same YAML format, the same Kubernetes constructs, so that developers don't even think about it, right? That's the premise, right? And so, apologies for the next section because I thought I was going to be able to show, like, actually I've got a live GitHub repo for all of this stuff. So what I did was, I put a QR code that you're welcome to take down. So what the QR code has is not only the repo, but the sets of things that are actually running in that repo itself, right? And a couple of the things that we've got running in that repo is a health API. So for all those that do APIs in the health industry, right, patient health records and stuff, there's an example application running there. Banking industry, there's a Bank of Anthos, which is a common application to test banking, and a GraphQL, right? GraphQL is an amazingly good place to do security and pen testing, right? And the intent with the demonstrations in the GitHub repo is to show you how everything is working without looking at a single security tool. You're using development tools to use all of these things. So the repository all works through GitOps, if you're familiar with GitOps, which means that I push code, the approval is done through Git, and everything else just works, right? Technologies such as Argo, CD, and Flux, they manage the consistent state between the GitHub repo and your runtime, eventual consistency, which means if you ever go and change anything in your Kubernetes environment, the Argo CD, or if you use Flux, will say, hey, this is not the same thing as what I've got in my repo. It'll go back and change it. So the intent of I've got a few slides on it, but at least in the repo is you go and change a policy, you go and change the application, everything just works. Right? So I'll just show you quickly what some of the things on the repo are, instead of just talking about them. So a couple of things that I want to sort of highlight: OpenSSF scorecards and best practice, right? I'm just doing a time check. OpenSSF scorecard and best practice. When, as developers, you start integrating with other systems, you really should check how often those other third-party tools are being updated. And this is more around, some of my colleagues will be talking about open source governance, right? So whenever I go use a repo and go, hey, that does exactly the same thing that I need, then I go and check, when was the last time that was maintained? Is someone still looking at it? Is it just one person doing that code, or is it a company, or is there lots of things? You need to think about these things, right? So the badges for the OpenSSF, which you can actually put on all your repos, does a set of checks automatically and gives you a score. A score of 8 and above is quite good. Other things that it does in terms of development work, you should always protect your main branches. Always, no one should be able to ever force push into main. You should always create separate branches and things like that. Lastly, I'll just go into things like dynamic scanning testing, right? So OWASP have a scanning tester called ZAP, which you can test your APIs and your applications against. Right, these things, security people, like I said, they would put that into your pipeline. Should never run in your pipeline. It should run asynchronously outside of your pipeline and then go and create issues as needed for all of the things so that you can go fix them. Right? Just on making a web application and API and DOS protection at the Kubernetes layer ridiculously easy. So, hopefully the font's not too small. On the right-hand side, you can see here, that's the policy. Blocking mode or transparent mode. That's it. You don't need to know anymore, right? You don't need to do, what is this new technology I learnt about, or new CVE I learnt about, blocking, non-blocking. At the Kubernetes layer over here, this is defining an ingress policy, right? You would have to define an ingress policy for exposing any one of your APIs or applications, right? You just say, please use that policy. That's it, all right? Now, typically when I talk to folks about this sort of stuff, what's the first thing that goes through their head? Well, I've used this type of technology before, but I'm worried about false positives. You're going to break my application. Right, but when you're working in this kind of pipeline model, your functional tests are part of your pipeline, right? So they should be running after your WAF is in blocking mode. So you're not going to have a false positive or your functional test is wrong, right? So the intent here is to show that after you're in your pipeline, that you've deployed things like runtime controls, like web application firewalls, authentication, all of these things, do your functional testing after that. If it fails, then you know there's a problem with the functional test, or you can go back and look at the technology. This is, again, working within the way that developers work. Another sort of thing that I sort of want to highlight here, this is just a security thing that no one ever talks about. Whenever you use GitHub repos, you really should check where you're running all your actions from and who you're getting all your actions from, right? Because whenever you run a GitHub runner, you're actually running someone else's code that's doing all of your build. Now, what you actually get is the output of the thing that you wanted, right? Oh, it went and changed my label. Oh, it went and did this. Oh, it went and did that. What else did it do? Well, you know, there's been known attacks of being able to take all of your environment keys, shift them off. This is how breaches happen, right? So at least one of those, this is an open source tool that you can use on your GitHub repos. What it does is it actually shows you what are the egress connections out of that GitHub runner and blocks it if you didn't allow them, right? So again, these are probably boring things to most developers, but this is like security things working within development ways in order to get the same level of controls, right? And lastly, security people, they only like one sort of dashboard. It's always the same. It's a worldwide map with lots of attacks, signatures, threats you've never heard of, and we always look at those. But to a developer, it doesn't tell you anything about how the application's running. At no point in time is that telling you, how is my application running? All of the security tooling, including things like web application firewalls, should be reporting things like 4x errors, 5x errors. Why? Because the developer looks at a Grafana dashboard and looks at SLIs, SLOs, right? So if someone looks at their dashboard for their application or service and says, my 4x errors just went up, what's the reason for that? They go and check that. Was that because of a security incident or because of something operationally they did? Similarly, my authentication request just went through the roof. I've noticed it on Grafana. Am I getting a brute force attack? Right? You don't need to use security tooling to do this, right? You're already graphing all of these things, right? So just to key takeaways, just to close this out, in terms of what things we can do to increase security for APIs, is start looking at the runtime or the infrastructure environment for security and not just concentrating on the static testing. You know, I did a webinar with Forrester last week and we both agreed on the call, we were laughing. We told the whole industry to shift left. We should have said shift left as well. Or shift everywhere now we call it, right? Because we forced everyone to shift left and forget about the right. Secondly, this is more for security folks, is to start small, then increment, not throw the kitchen sink at controls. You know, I was talking to a gentleman earlier this morning about IPSs and things, and the problem I said wasn't the IPS, the problem was it took them 2 weeks to go find out and troubleshoot, right? So it's not the control, it's like the time that it takes to get all of this information. And last two, because I know I'm running out of time, is integrating DevOps processes for security tooling as opposed to just shoving tools in, right? This is why that first set of steps happened, right? Developers will just bypass it, right? If it's not providing value, it'll bypass it. Lastly, it is always the intent to have security across every single application. Breaches do not happen just on your PCI compliant app or where your credit cards are. They will come through the path of least resistance. And the path of least resistance is probably where you said, I probably don't need this control or this control, right? So the intent is to have security across all apps everywhere. And the reason it hasn't been done is because security hasn't been ridiculously easy, effectively. Thank you.
Hey Shane, thanks for the insight sharing on the safeguard APIs in modern ecosystem. Next, let's explore the synergies between data and APIs and uncover the power they hold when combined. Supported by data literacy.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.